In this video, we are going to create an expert advisor that utilizes the accumulation distribution indicator along with buy and sell trailing stops. Let's see how we can do that. We start Metaeditor by clicking a little icon or pressing F4. This will open the environment where we can write our MQL code. The first part of the code includes the necessary library for trading operations. This class is essential for managing all trade operations, including position management. Next, we instantiate a CTrade object named Trade. This object will be used throughout our expert advisor to execute trades. Following that, we define our strategy configuration parameters. These parameters are adjustable in the EA properties. The first parameter, Lookback Bars, is set to 50. This parameter determines the historical range for highs and lows, allowing us to analyze up to 1,000 candles. The second parameter, Min Candles Back, is set to 5, which specifies the minimum age for a valid high or low, ensuring that we only consider recent data. The third parameter, Trailing Offset, is set to 10.0, which defines the safety margin for the trailing stop in points, with a range from 1 to 20. We then declare global variables and handles to store state between ticks and indicator data. The variable add handle will hold the handle for the accumulation distribution indicator, while add buffer is an array that will store the A/D values. The price data array will hold the open, high, low, and close price data. The onInit function is executed once at the start of the expert advisor for indicator setup. Inside this function, we create the A/D indicator handle using the IAD function. This function takes the current symbol and the H1 timeframe as parameters. The A/D indicator does not require additional parameters. We also configure the arrays as time series using ArraySetAsSeries, which ensures that the newest data is at index 0, aligning the indexes with natural time progression. After setting up the indicator, we return the success code init_succeeded to indicate that the initialization was successful. Next, we define the functions for opening buy and sell positions. The open by position function retrieves the current ask price using symbol info double with the symbol_ask parameter. It then executes a buy order using the position open method from the CTrade class. The parameters for this method include the symbol, order type, volume, price, stop loss, take profit, and a comment. In this case, we are opening a buy position with a size of 0.10 lots, which translates to 10 micro lots, at the current ask price. Both the stop loss and take profit are set to 0, meaning they are disabled. The open sell position function operates similarly. It retrieves the current bid price using symbol info double with the symbol_bid parameter and executes a sell order using the position open method. Again, we specify the symbol, order type, volume, price, stop loss, take profit, and a comment. Here, we are opening a sell position with a size of 0.10 lots at the current bid price, with both stop loss and take profit disabled. The onTick function is the core of our strategy and is executed on every tick. Inside this function, we first retrieve historical price data for analysis using the copy rates function. This function takes the symbol, timeframe, start position, count, and target array as parameters. We copy H1 candle data for the specified lookback period into the price data array. Next, we load the A/D values from the indicator buffer using the copy buffer function. This function takes the indicator handle, buffer number, start position, count, and target array as parameters. We copy the calculated A/D values into the add buffer array for trend analysis. We then check the status of open positions. We initialize a Boolean variable as open position to false and set the current position type to position_type_buy as a default value. We loop through all open positions in reverse order to safely iterate and find relevant ones. For each position, we get the unique ticket number using position getTicket. We check if the position belongs to the current symbol using position select by ticket and position getString with the position_symbol parameter. If we find an open position, we mark his open position as true and store the type of the current position. Next, we implement trend detection and position management. If the A/D value is increasing, indicated by add buffer 0, being greater than add buffer 1, we check if there are no open positions. If there are no positions, we call the open by position function to open a new by position. If there is an open by position, we identify the low point for the trailing stop by finding the index of the lowest low in the lookback period using the iLowest function. We retrieve the last low price from the price data array. We then check the trailing stop conditions. The low must be at least min candles back old, and the current price must be above the identified low. If these conditions are met, we calculate the new stop level by adding the trailing offset to the last low price. We then call the process trailing stop function to update the trailing stop for the buy position. If the A/D value is decreasing, indicated by add buffer 0, being less than add buffer 1, we follow a similar process for sell positions. If there are no open positions, we call the open sell position function to open a new sell position. If there is an open sell position, we identify the high point for the trailing stop by finding the index of the highest high in the lookback period using the iHighest function. We retrieve the last high price from the price data array. We check the trailing stop conditions for sell positions. The high must be at least min candles back old, and the current price must be below the identified high. If these conditions are met, we calculate the new stop level by subtracting the trailing offset from the last high price and call the process trailing stop function to update the trailing stop for the sell position. The process trailing stop function is responsible for managing the trailing stop for both buy and sell positions. It iterates through all open positions in reverse order. For each position, we select it using the ticket number and check if it matches the specified position type and belongs to the current chart symbol. We retrieve the current stop loss value using position get double with the position_SL parameter. For buy positions, we check if the new stop level is higher than the current stop or if there is no existing stop loss. If either condition is true, we call the position modify method to update the stop loss. For sell positions, we check if the new stop level is lower than the current stop or if there is no existing stop loss. If either condition is true, we also call the position modify method to update the stop loss. Finally, we press F7 to compile the code. If this was too fast for you or if you don't understand what all the code is doing, you may want to check out the premium course on our website or watch one of the basic videos first. If everything works, we go back to Metaeditor by pressing F4 or clicking on the icon. Back in Metaeditor, we press Ctrl and R to start the strategy tester, pick the expert advisor that we have just created, enable the visual mode, and start a strategy test. We should see the expert advisor on the chart. If you are already a premium course member and have an idea for a video like this one, you can send us an email. In this video, we have learned how to create an expert advisor that utilizes the accumulation distribution indicator and implements buy and sell trailing stops. We have coded this functionality with a few lines of MQL code. Thanks for watching, and I will see you in the next video.